There are 10 basic convergence tests for infinite series in our book. This is the very first one, and it's only a rule out test. It can only prove that a series diverges. It cannot prove that a series converges. Like the TSA, first thing they do is look for that visible gun test. It's like that. You see the visible gun, it proves the person's not allowed on the plane. If you don't see the gun, that proves nothing. Right, the test. Fill in the blanks, pause the video. Here's the test written out for a series. Here's a series written in standard notation for general series. Okay. If the terms don't start doing what at some point, then the series what? Okay. If the terms don't start shrinking toward what? Zero. The terms must get smaller and smaller and smaller, closer and closer to zero at some point. They don't have to at first. You could have 10 plus 10 plus 10 plus 10, but then eventually, to pass this test, the terms have to start shrinking to zero. So if they don't start shrinking to zero at some point, then the series diverges and is useless to us. Here it is written in more mathematical notation. Here's the general signal notation for a series. And I've written what that means over here just to remind you, but it doesn't have to start at n equals 0. So I put n here. It could start at any n. So that's the general notation for series. But when you write out the test, you don't write the series. You're talking about what the individual terms are doing. So you have to write a sub n. And we want to look at a sub n as what happens as we go like this. So what number is changing here as I go like that? The n is. And what's happening to the n? It's getting bigger and bigger and bigger. So this is actually a limit. Limit as n does what? And you should write arrow and then infinity symbol, meaning the limit as n increases with no n to it. We just look at what happens as we let n get bigger and bigger and bigger. And what do these terms have to do? So if the individual terms do not approach zero, see, this is in English. This is how you write it in math. You look at the individual terms, you let n get bigger and bigger and bigger, and you look at the limit of what the terms are approaching. And if that limit is not zero, then what goes in there? And the series, we don't say the terms diverge, right? They're two different things, what the terms are and the series as a whole. So if the individual terms do not approach zero, then we say the series diverges. The terms don't have to diverge. The terms could approach a finite value like 2. The terms just, if they don't approach 0, then the series diverges. Okay, now notice this is very important. What if it passes this test? If the individual terms have a limit, as n gets bigger and bigger and bigger, and that limit is 0, then what does that tell you? That tells you nothing. TSA, looking at a passenger, does not see a visible gun. That really tells you nothing about that passenger. Nothing important. They still might have a concealed weapon. All right, here are some 3 examples that will help you with the homework. Look at this. This is implying that the terms are shrinking, but they're not shrinking towards 0. These individual terms are approaching 2. So if you ask the question, are the terms converging? The answer is yes. The individual terms are converging to 2. But that's not the question we're asking. The question we're asking is, does the series converge? Can I draw a line that these steps will never cross? And the answer is no. So this diverges. This series diverges. Okay, let's look at this one. Are the individual terms shrinking? Yes. Are they shrinking and approaching 0? Yes. So this passes the test. But what does that tell you? It tells you nothing. It tells you you have to use another test on this series to see if it truly does converge. And by the way, this particular series diverges. Even though it passes that first test, we will learn in a future test that this series diverges. Okay, here's our last one, and this is what the homework looks like. Here's the series, very complicated, but remember what we're doing. We're looking at what the individual terms approach as n gets bigger and bigger and bigger, and that's going to make this an easy problem, not a difficult problem. Don't try to plug in numbers. Don't try to plug in n and look at what individual terms do. That's a nightmare. This is one of the reasons you did all that study of limits last year in AB, and you do it this year in BC. So you can look at this as a limit. limit as n gets bigger and bigger of this. This is the term. So use your tools for limits. You ignore the terms with the smaller exponents. You only look at the leading one of each, where the exponent is biggest. This makes a 1, and so that means that these individual terms approach 3/5. That the limit as n gets bigger and bigger of the individual terms is 3/5. Is that equal to 0? No. Therefore, this series diverges.